Let's focus on angles of elevation and depression today. An angle of elevation is an angle that is moving up from our horizontal line of sight. So if we're looking straight out, the angle that your eyes are going up is the angle of elevation. An angle of depression then is the angle going down from your line of sight. So if we're up here in this hot air balloon and we look down at the person below, that angle is our angle of depression. So let's look at this first example and see if we can label these. Angle 1, if this is our line of sight, we are looking up, so that's an elevation. Angle 2, this is our horizontal line of sight, and we are looking down, so angle 2 is a depression. Angle 3 is also looking back up, so it's an elevation. And angle 4 is this whole angle, and we're looking down, so it's a depression. So in this example, we want to write two trigonometric equations that we can use to find x. So first of all, we can look at, we know right here we have our angle of depression is 23 degrees. So if we wanted to find out this angle, we know that both of them add together to be 90. So if we do 90 minus 23, we're going to end up with 67. So this angle is 67 degrees. So if we wanted to write an equation, we could say the tangent of 67, because this is the opposite side, and this is the adjacent, is the same as x over 210. In a different equation, if we didn't want to use that angle, we want to use the 23 degrees, we can look at it and say, okay, well, this distance is x, it's the same from here to here, up here, and this height is also 210. So we can look at this is still our opposite, and this is the adjacent. So we can also write that the tangent of 23 equals our opposite over our adjacent. So those are the two different equations we can write, depending on which one you would like to use. Alright, let's look at this. We want to compare the values of x to the value of y. So let's start off by looking at our degree, which is 42. And we know this side is our opposite, and this is our adjacent. So we're going to be working with tangent. So the tangent of 42 equals 56 over x. So if we do that, the tangent of 42 is 0.9, so 9/10 equals 56 over x. So when we cross multiply, we end up with 9/10 times x equals 56. So when we divide both sides, x equals 62.2. That's in feet. So let's take a look at the other side so we can find y. So we're looking at this triangle now. We know our angle of depression is 54. So we know this whole angle has to be 90. So if the whole angle is 90, that means this little one is 36 degrees. So we're still looking at, this is our opposite. This is our adjacent side now. So we can say, well, the tangent of 36 equals the opposite side, which is y, over our adjacent, which is 56. The tangent of 36 is 0.726. So we can cross multiply, and y equals 40.6 feet. So when we compare x and y, x is longer than y. Alright, we want to find the height of a tall tree. So we're looking at a tree. We don't know how tall it is, but we know that a surveyor is at the base of the tree, and they move 140 feet away from our base of our tree. This surveyor also stands on a transit that's 4 feet tall, so that means he is 4 feet in the air. So he's standing up here. We want the measure of angle. So when he's standing up here, he's looking up at the tree, and the angle he forms is a 53-degree angle. So right now, his line of sight is there. So what is the height of the tree? X. So we are going to be working with this angle, working with the opposite and the hypotenuse. So the tangent of 53 equals x over 140. So the tangent of 53 is 1.327 equals x over 140. So when we cross multiply, x equals 180, so it's to the nearest foot, so 186 feet. But the thing is when we did this, he's 4 feet in the air, so there's an extra 4 feet we didn't account for. So if we add 4 more, this tree is 190 feet tall. Alright, we have a meteorologist measures the angle of elevation. So that means he is looking up at 41 degrees. So here's his line of sight, horizontal. He's looking up at a weather balloon. So there is a weather balloon up here in the air. He's looking up at it, and the radio signal from the balloon indicates it's 1,503 meters from its location. We want to know to the nearest meter how high above the ground the balloon is. We don't know x. So if we look at this, we're looking at the opposite side compared to our degree and the hypotenuse. So if we're working with opposite and hypotenuse, we're going to be looking at the sine of 41 equals x over 1,503. And the sine of 41 is 0.656. So we can cross multiply. X equals 656 times by 1,503. The balloon is 900. I want it to the nearest meter. So 986 meters above sea level. Alright, last problem. The world's tallest unsupported flagpole, so we have a flagpole, is 282 feet tall. The shortest shadow it casts, so it casts a shadow on the ground, which is 137 feet. To the nearest degree, what is the angle of elevation? So angle of elevation is this angle, and we don't know what it is. So if we're looking at our triangle, this is our opposite side, this is our adjacent. So we're working with the tangent of x equals the opposite side over our adjacent, which is 137. So if we want to find the angle of x, we want to find the inverse tangent, 282 over 137. So when we use our calculator, divide the two, we get that the angle of elevation is 64 degrees.